In this video we'll take a look at the temperature dependence of equilibrium constant. And I'm specifically looking at chemical reaction equilibrium constant for a gas phase reaction. So there are other types of equilibrium constant and they can occur in other phases other than the gas phase. But we've got this very general generic form of chemical equilibrium here, where we've got different stoichiometric coefficients and chemical formulae for reactants and products. So the symbol, the Greek letter nu, is the stoichiometric coefficient for each individual component, and then capital X is the chemical formula. So it's just a very generic form. Pi is the partial pressure for each of the components, and P superscript 0, or rather superscript circle, is the standard pressure. And we can work out K, the chemical equilibrium constant, with the equation that's shown here. So we've got the products on the top line, and it's the partial pressure of each product divided by the standard pressure raised to the power of the stoichiometric coefficient. We go through this for each component of the products on the top line, and the reactants, same form but on the bottom line of the fraction, as it were. Okay, in terms of temperature dependence, we have log K equals minus delta G over RT. So we can put this into the form of thinking about reaction, delta G of reaction at T2, that's the temperature that we're interested in, and we can find out something about the temperature dependence of delta G of reaction if we know something about the entropy change of that reaction and the enthalpy change. Now we have equations for their temperature dependence from previous videos, so that depends on having a Cp in the form of Cp divided by R equals A plus Bt plus Ct squared plus dt to the minus 2. So now that we know that, we can actually plug all of those values in, get the delta G of reaction at the temperature that we're interested in, temperature 2. Temperature 1 is just the reference temperature where we have reference values for everything, and we're able to work out what is the equilibrium constant at that temperature. Of course, remembering that we've got these other equations here. And as I just mentioned, T1 is the reference temperature, normally 298.15 Kelvin. Okay, so that's been a video about the temperature dependence of chemical equilibrium constants. I hope you found that useful. Please remember to like, comment and subscribe, and thanks very much for watching.